As I think I mentioned before, last year we had terrible confusion about what data I had and where I'd put it for you and where you could go to get your data in the future. So here's a hopefully quick overview of all the data that we have for the CephC-LABS project. We've got data from a lot of different places, and so on the wiki, on our page about all of the things that we're doing, not that it's very well populated, there's a link to the CephC-LABS data list, and that's what I'm looking at. So it sort of looks like the table that was in our proposal. So we have the telescope survey, we have wavelengths, we have where you can get the data from its original source, and then where to find it on the box drive that I've created for you. So the ACIS, the Chandra ACIS data are X-ray data, but we're not going to work with the X-ray data, so I didn't put it in the box drive for you, but you can get it if you want from the original Chandra archive. Sloan is optical, UGRINZ bands. You can get it from Sloan directly, but I find their interface to be a little frustrating. So I like getting at it through the URSA tool called Finder Chart. It will give you small tiles. If you want a big tile, you need to use Skyview and be careful of the pixel sizes that you're selecting. So where do you find it in the box drive? When you look at the box drive, you see it on the web. But when I see the box drive, it looks like a part of my disk. So in the images subdirectory, in order to find the Sloan data, you go and find the directory is called SDSS. And it's -Skyview to remind you and me that these tiles are coming from Skyview, not from Finder Chart or Sloan. And then the name itself, note that alphabetical is not wavelength order. So it's UGRIZ for wavelength order. Pan-STARRS is the next one. It is similar, but not quite the same as Sloan. It has GRINZ like Sloan does. It doesn't have U, it does have Y, which is further into the infrared. Again, you can get the original data from Pan-STARRS. I believe our data covers the whole area. Our whole area has Pan-STARRS data, but I only grabbed you a tile that covers a good chunk of the area. So if you go to the Pan-STARRS directory, there's the Pan-STARRS images. IFAS, the data page for IFAS. IFAS is 3 bands, optical, RI, and H-alpha. H-alpha is narrowband, R and I are broadband. You can get the original data there, but in order to find the specific objects that they identified as having a clear infrared access, you need to go to the literature to identify those sources. And again, IFAS data, I believe there are data over the whole area, but I only grabbed one tile. So if you go to the IFAS directory, now these are compressed files, but Skyview should still, DS9 should still know what to do with them. There are several different tiles, I think, there. There should be 3, one for each wavelength, but you'll have to get in and look at them to see exactly which is which. Okay, 2MASS. 2MASS has JH and K, it's near infrared. Again, you can get the original data. You can get it from Finder Chart, but Finder Chart is going to give you only small tiles. So to get larger tiles, you have to get it, for now, from Skyview. So again, if you go over here, 2MASS-Skyview to remind us that the data are coming from Skyview, and those are the big tiles. Now, Spitzer. Spitzer gets complicated because there are different kinds of data taken at different times, and remember there is time matters for some of what the whole point of the Spitzer data. So let's do the easy one first. When Spitzer still had cryogen on board, it could observe in 4 channels of IRAC and 3 channels of MIPS, but we're only going to use the 1 channel from MIPS, the 24 microns. So there's 4 bands of IRAC and 1 band of MIPS. If you go to the Spitzer Heritage Archive, that is the place to go to get all the data ever taken by Spitzer. But this row is talking about just the data taken when we had cryogen on board. In other words, data taken during the first 5 years of the mission. Now, to further complicate matters, we've got several different reductions of the same data. So there's one data reduction, which is done by the Spitzer Science Center as part of something called SEIP, Spitzer Enhanced Imaging Products. So in the process of generating those SEIP products, what they did was they summed up all the available data for the cryo era. So they have all 4 bands of IRAC and MIPS 24. They have big tiles, which is good. They have reduced photometry, which is okay. They don't go as deep as we need them to go, but they have a lot of the data that we need. Then there's data that Rob Gudemuth reduced for us. I don't have those mosaics. I do have the photometry from Rob. Then I ended up making mosaics myself for 3 different channels because I didn't like something about what the SEIP mosaics were doing. Maybe it was the coverage. There was something, I don't even remember. But I summed up my own my own data for I1, I2, and MIPS1. So if you go over here, there's one directory for Spitzer that has several different subdirectories. SEIP are the mosaics done by the SSE as part of the SEIP process. Note that there's 2 for each IRAC band. What it did was, because this is a bright region of the sky, the people that designed the observations took one short exposure and then, well, I guess several short exposures and several long exposures. The short exposures are going to be only sensitive to the brightest objects, and the deep exposures are going to try to reach the fainter objects, but at the expense of the brighter objects, which will be saturated. So there's mosaic and short mosaic. Short mosaic is really only valid for the bright sources. Like I said, I don't have the mosaics from Rob, but then my own summary. If you go here, my cryo, you'll see my own summaries, my own summed up mosaic images for IRAC 1, 2, and MIPS 1. These tiles are custom to what we're doing because I made them, so these are the data you should probably use in general if you're working with the images directly like this. Now, during the post-cryo era, after we ran out of cryogen, there were 2 different projects that observed this region. GLIMPS is a survey of the galactic plane. They started when there was cryo, and in the years since then, they've just kept marching through the galaxy. There are several sub-projects for GLIMPS. The data that we're using come from a sub-project called GLIMPS 360. Because they're working over the whole galactic plane, their aim was to cover area, not to go very deep. So it's pretty shallow. It pretty much catches on the brightest objects. Those data live in the Spitzer directory and then the GLIMPS subdirectory. And because it's post-cryo, those only channels 1 and 2. Finally, the YSOVAR data, again, taken post-cryo, so there's only 2 IRAC channels. If you go to my YSOVAR, you'll see just 2 mosaics rather than the 100 or so epochs that we have. What I did was I summed up all the available data for IRAC 1 and 2, which means that this is going to go incredibly deep. It's going to go to very, very, very faint objects. But it has got a funny edge to it because it's, taking into account all of the YSOVAR data. It's not a square, it's unusually shaped. Then there's Ys. You can get 4 bands of Ys between 3.5 and 22 microns. You can get it directly from the Ys archive, or you can get it through Find Your Chart, and they give you pretty large tiles. Those, confusingly, are in the Find Your Chart files directory because I thought it was useful to keep a record of the fact that these are coming from Find Your Chart. And so you have the tiny 2MAS tiles, the Sloan tiles, the IRAS tiles, the small Sloan tiles, and then here are the Ys tiles. Then for Herschel, we've got PAX at 70, 160 microns and Spire at 250, 350, and 500 microns. You can, now it shouldn't say Ys archive. That's not right. I should fix that. The HHLI is Herschel high-level imaging. So they give you pretty large tiles, but they've stripped off a whole bunch of infrastructure that the Herschel reduction software needs, but that you don't. And I cropped them down for you and pulled these things into just one single plain fits files as opposed to many files because the Herschel tiles are enormous. So if you go to the Herschel directory, PAX cropped, you can see those are the 4 tiles for 70 microns, and there's 2 tiles for 160, and then for Spire, 250, 3, okay, so there's 2 tiles, 250, 350, 500, 250, 350, 500. The coordinates here are galactic coordinates specifying the tiles. And then finally, the scuba data. The scuba data you can get through the main archive. I have lost track of exactly where I got these data. I think it was from the main archive. But you'll have to find, for the photometry, you have to look at the literature, the DiFrancesco et al. Paper. And then the scuba directory has the information. It also has the DiFrancesco table in regions file format, but also IPAC table format. This is things for the extended sources, but what we want are these. So again, the scuba data are very different than the other data. If you just load them into DS9, you'll see right away they look very different, and you'll need to use a different stretch for the scuba data compared to the others.